So remember with the law of sines, in order to use that to solve a triangle, first, the triangle cannot be a right triangle, because if it's a right triangle, you want to solve through sine, cosine, tangent, and the Pythagorean theorem. So let's first draw a triangle and see the information that we're given. Again, it doesn't matter where you label A, B, and C. Okay, that doesn't matter. What matters is that the given information is accurately labeled. So angle A was 35 degrees. Little b is 14. And then little a is 6. Just a reminder that the corresponding sides are always across from their angle. So little a is the side across from angle A. Okay, well, in order for us to use the law of sines, we need one corresponding pair. And we have that. We have angle A and little a. Sweet. So since we have little b, let's go ahead and find angle B. Using the law of sines, I'm going to set up the sign of the corresponding pair, so big A over little a, equal to the sign of big B over little b. Why? Because we were given little b, so we have to use b. All right, plugging in what we know that big A is 35 degrees. We know that little a is 6. And this is going to be equal to the sign of big B over little b, which is 14. Nice. Okay, so cross multiply with me, please. So we get 14 times the sign of 35 degrees is equal to 6 times the sign of capital B, whatever that angle may be. And then I'm going to have the sign of B equal to 14 times the sign of 35 degrees all over 6. But we are not done, ladies and gentlemen, because we are finding the angle. Remember that in this case, we want to use the inverse, yeah? So I'm going to take angle B and I'm going to set it equal to the inverse sign of the ratio, which is 14 times the sign of 35 degrees all over 6. Go ahead and put it in your calculators and let me know what you find. Make sure that your calculator is in degree mode, please. We are dealing with angles in degree measure. Okay, what do we get? Nobody. Are you all nervous? What if my answer's wrong? But what if it's right? How many of you, your calculator can't do it, Colin? Throw it away. It's obsolete. Get a new calculator. Just kidding. Colin, what is your calculator saying to you? It's telling me error. Oh, Shannon's didn't do it either. Emma?
Me too.
Same thing. Carter?
Yeah.
Dean? Same thing? Okay, so how many of you think that you did something wrong? Okay, that is possible. Here, let's do it together. Carter thinks she did the parentheses wrong. That's always a possibility. Make sure everybody can see it. Okay, so we need to put in, oh fudge, what is it? 14, right? Times, what's in the numerator? 14 times the sign of?
35.
35? Okay, thanks you guys. And then we're dividing that by 6. Thank you. Just because I can't see it and I forgot to take a picture. Okay, so 1.333333, right? And then we take the inverse sign, so I'm hitting the second button, of the answer. So I'm going to hit second answer. What? How is that possible? Think about what sine represents as a ratio, yeah? Sine is, of any angle, is, oh fudge, there we go, opposite over hypotenuse, right? Regardless of what right triangle, we know that's a true statement. Well, isn't the hypotenuse always the longest leg of a triangle? Yeah, right? Okay, so if the hypotenuse is always the longest leg, interesting, I have a fraction where the denominator is always the longest leg, so what number can this fraction never be greater than? If the denominator is always the biggest number, the longest side, oh no, good guess, Dean. Dean said 14, no. Just, huh?
6.
No, good guess. Don't think about this triangle specifically, okay? Think about if I have a sine ratio, and regardless of the numbers, the denominator is always the longest side. Think fraction-wise, right? What can this ratio never be greater than? What number can it not go over? I'm opening my other chat. Oh, nope, I'm not. It's not letting me. Yeah, Dean K?
Is it 1?
It is 1. Very good, sir. Because the numerator can never be bigger than the denominator. Excellent. Very good. So, oh, hello. Oh, Shannon, I just saw that. Nice job, too. Shannon said 1 as well, but I couldn't open my chat. It's very annoying. Okay, so if the sine ratio can never be greater than 1, do me a favor, you guys. Put this into your calculator. What is the inverse sine of 1? Yeah, Kyle, what is it? I hear you.
90.
Yeah, it's 90 degrees. Whew, okay, 2 very important pieces of information here, you guys. First, if the sine of theta can't be greater than 1, then we can't take the inverse sine of 1.3333. That can't happen. Okay, so you can never take the inverse sine of a ratio larger than 1. Why? Because of this very important piece of information. So, this triangle is not possible. The given information is not possible for this triangle. The second piece of information is that if the inverse sine of 1 is 90, that means that we will never get an obtuse angle from using the inverse sine. When you're using the inverse sine, you're always going to get an acute angle measure. Why? Because of this whole relationship. So, when you're using the law of sines to solve a triangle, you must always solve for the smallest angles first. Why? Because inverse sine will not give you an obtuse angle. And if there's an obtuse angle in your triangle, well, shoot, I'm not going to solve and find it this way. Now, if you're thinking, yeah, how do I know where my small angles are? Let me give you an example. We have this triangle. Doesn't matter what we label it. ABC, MNO, doesn't matter. But we're told that we have a side of 3, 7, and 15. The biggest angle is always across from the longest side. The biggest angle is always across from the longest side. The smallest angle is always across from the smallest side length. Okay, really important information to think about, you guys. Now, going back to example C, oh man, we didn't even stop to think about the information that was given to us. It was given to us as angle, side, side. Uh-oh, angle, side, side. Is this one of our congruency theorems? No, right? And in fact, most of the geometry teachers will say, oh, you can't use that, it's a bad word, right? We can't use that to prove triangles are congruent. Well, the reason being is because you could get one triangle, you could get no possible triangles, as we saw here, or you could have two triangles from an angle, side, side situation. So, ladies and gentlemen, that leads us into skill 3 today. If we're given the angle side-side combination, we could potentially have two triangles, one triangle, or no triangle. And this is called the ambiguous case when there are two triangles. Think of what ambiguous means, right? Unclear. So it is unclear whether we have two triangles and which triangle to solve for. Now, how the heck do we figure this out? Well, think about if we're given angle, side, side. So I'm just going to label this A, B, and C. And we will be given angle A, and we will be given little b. And for the time being, we'll just draw little a like this. Well, this is not a right triangle, right? But I do need to figure out if little a is going to meet the base of my triangle, because I'm only given angle, side, side. So I somehow need to test, will little a meet the base of my triangle? Well, shoot. That means I need to compare it to the height, because if I have a perfect length of a height, I'm going to have one triangle, right? Okay, so thinking, gosh, well, this is my height, and I need to compare A. Could I, and this kind of leads us back to what we saw last week, could I say that the sine of angle A is equal to the height over the base? Is that a true statement since I dropped the altitude? Can I say that? Is the sine of angle A equal to the height over the base in my generic triangle? Yeah, because we have the angle A, right? That's our given angle. And then it's equal to the opposite over the hypotenuse. So that's okay. Oh man, okay, but I'm trying to compare the height. So let's say I multiply both sides by b. Okay, so now the height is the product of b sine A, correct? And we actually saw this with the area formulas. Whoa, what was this, last week? Where the height can be represented as the product of the non-corresponding side and the sine of the given angle. Everybody still with me still? Okay. So, since this is my corresponding side, I need to test and see, is it the length of the height? Because if it is, it's going to meet the base, right? If, oopsies, not the color I wanted. If I'm given this situation where this is A, this is my given angle measure, I have little b, and then I have little a. If little a is less than the height, it's never going to meet the base because it's less than the height. Okay, when we are given triangle measurements in the order of angle, side, side, we need to test and see if the corresponding side is less than, equal to, or greater than the height. Because that height is what's going to meet the base. Everybody with me still? Kind of, sort of, ladies? Yeah? Okay. So, if there's no triangle, a couple of things have happened. First, the given angle. Notice I'm saying the given angle, not just the measure of angle A. The given angle is less than 90 degrees, so it has to be acute. And it follows suit that the corresponding side is less than the non-corresponding side. Well, if this is the case, then the corresponding side, when tested with the height, which remember, we found that the height can be represented as the non-corresponding side times the sine of the given angle. If the corresponding side is less than the height, it's never going to meet the base. No triangle exists. And we're sad. Although I find that students are usually really happy in this situation because they don't have to solve for a triangle. I don't know why that's not going away. There we go. Okay. Now, let's say that the measure of angle A, so the measure of the given angle, is still less than 90 degrees, and the corresponding side is less than the non-corresponding side. If we test the corresponding side against the height, which we know can be represented by the product of the non-corresponding side and the sine of the given angle. If we test that and we find that it is equal to the height, that means we are going to have one beautiful triangle Again, we're given angle A, we're given little b, and little a creates one triangle. Okay, well, what if the measure of the given angle is still acute, right? So it's less than 90 degrees, and the corresponding side is less than that of the non-corresponding side. We've seen it be less than the height. We've seen it be equal to. What if the corresponding side is greater than the height? So it's greater than the non-corresponding side times the sine of the given angle. In this instance, there are two possible triangles because it's greater than the height. So the first possible triangle, still A, B, C, still given angle A, still given little b. If I'm greater than the height, I can't go straight up and down because I'm longer than what that length would be. So I could create a triangle where I am a little bit to the right of where the height would be. Or I could create a triangle still given angle A and little b, where I am a little bit to the left of where that height would be. Because I'm greater than the length of the height, I can't go straight up and down. I would extend past the base. So I'd either have to be a little bit to the right or a little bit to the left. We don't know which one, so we have to solve for both. That's the ambiguity of it. But, Ms. Patterson, these are all acute angles. What if the given angle is obtuse? Good question. Well, if the angle that is given to us is obtuse, there is only one possible triangle that could come from that. So if the measure of the given angle is greater than 90, it will follow suit that the corresponding side is also greater than the non. Then we only have one triangle. Wow, that's a lot. So good. There's so much analysis required. Now, do me a favor, please. As you are going through the homework, as you are practicing the law of sines and solving triangles, have this chart right next to you. Okay, I don't expect you to know it right off the bat. Have it there for reference and then start challenging yourself to remember it without having to look at the chart. Okay, also something else that you might want to write down is when we're comparing the given side or the corresponding side, with the height, you might want to write down for yourself that this is the corresponding side, because again, they're not all going to be labeled A, B, and C. Okay, we might have RST. Little b represents the non-corresponding side, and then angle A is the given angle. So please don't get wrapped up in A and B always have to be given. It's the given angle, the corresponding side, and then the non-corresponding side. So good, so good. Let's do it, you guys. You ready? Yeah, some of you look frightened. Don't be frightened. Here we go. Example number 7. We have a lot of opportunities for us to practice. This is great. Determine whether each triangle has no solution, one solution, or two, and then solve depending on your answer. Okay, well, first thing I'm going to do is draw a triangle and label the given information to make sure that I need to test. The only time I need to test is if I'm given angle side information. We're given that big A is 42, little a is 13, and then little b is 16. Okay, going in order without more than one gap in between, we do have angle side, so we know that this is a situation where we are going to have to test the given information. I'm going to examine the corresponding side, which is 13, in relation to the product of the non-corresponding side, which is 16, times the sine of the given angle, which is 42. Okay, so 13 times the sine of 42, making sure that your calculator is in degree mode. How does 13 relate to approximately 8.7? It is larger than. So if the corresponding side is greater than the height, that means that we have two possible triangles. Yes. So we're going to solve for both possibilities. Now, when you're given information as angle side, you're going to notice that my base, the way that I draw my triangle, is always the side that's not given. Okay, and this is on purpose, and you'll see why when we create the second triangle. Okay, so let's go ahead and solve for triangle number 1. All right, we have an angle pair with its corresponding side. So let's go ahead and use that. So sine of angle A over little a, and I'm going to set it equal to the sine of B, because the only other piece of information that we have is little b. Okay, plugging in what we know, I'm going to say that the sine of 42 degrees over 13, which is little a, is equal to the sine of big B all over 16. And then, in this case, we don't actually need to do the entire cross multiplication. I'm going to multiply 16 to both sides. So we get the sine of B is equal to 16 times the sine of 42 degrees all over 13. I'm then going to take the inverse of the ratio because I'm trying to find the angle measure. So 16 times the sine of 42 divided by 13, inverse sine. If we round to the whole, what is approximately the measure of angle B?
$55.
Yeah, thanks, Colin. I got that as well. So approximately 55 degrees. And I'm going to go ahead and write that in so I have a visual. I don't understand why it keeps popping up. Sorry, I'm having technical difficulties. No surprise. Okay, so we have big A, little a. We have big B, little b. I know nothing about C. So what I do know, oopsies, is that 3 angle measures within a triangle add up to 180. So I'm going to use that, this was our first step, to find the measure of angle C. I'm going to say that the measure of angle C is 180 degrees minus the sum of the other 2 angles. What is that? 97. So is it 83? Yeah, thanks you guys. Okay, so it is approximately 83 degrees. Now, you don't have to write the measurements into the triangle as you find them. I like to so that I know what I still need to find. In this case, we still need to find little c. This is going to be our third step to solving the triangle. Now, as mentioned before, I'm always going to go back and use the given information because it's exact. Okay, it is exact information. It is not approximated, so the rest of it won't be approximated as well. Here we go. The sine of angle A over little a is equal to the sine of angle C over little c. So I've got the sine of 42 degrees over 13 equal to, now we know that angle C is 83 degrees, so I'm going to say the sine of 83 degrees over little c, because that's what we're looking for. Okay, cross multiplying. We get little c times the sine of 42 degrees is equal to 13 times the sine of 83 degrees. And then trying to isolate c, I'm going to divide by the sine of 42. So we get 13 times the sine of 83 degrees all over the sine of 42. All right, what do we get?
19.
19 point.
19.9.
Oh, I got 19.3.
Oh, sorry, yeah, 19.3.
No, that's okay, that's okay. Thanks, Nadia. Okay, so approximately 19.3 units. Guess what, ladies and gentlemen? we have solved the first triangle.